Hello friends, this is Suresh. We're going to discuss about AlexNet, best practice toward AlexNet, its architectures, what we will cover what is the AlexNet, our architecture. AlexNet famously won 2012 ImageNet LSVRC 2012 competition by large margin 15.3 vs 26.2 second place error rate. So ImageNet is the large scale visual recognition challenge that will happen in 12, 13, 14. Yeah. So that is a large data set of image for image classification purpose. So it's a big history that time in 2012 that AlexNet won the challenge. So this is the basic history of IELTS VRC challenge in 2010 started, then 11 that shallow decreases by 25.8 to 16.4 error rate, and AlexNet that time so popular. Then so on the other network will come in picture and decrease that error rate. So we discuss all of the network, then come to the AlexNet. So basically they cover what they time. We are retrace the history here only. Generally people are not using AlexNet, but what they are what they did that time, that we going to discuss about. So basically the previously competitions people are using 10H for non-linearity, for add non-linearity, but here AlexNet reduced to use ReLU instead to 10H to add non-linearity, and it's accelerate the speed by 6 times at the same accuracy. So ReLU increase speed up, and the previous training taking longer time, but AlexNet much faster. They use dropout instead of regularization to deal with overfitting. However, the training time is double with the dropout rate of 0.05. And overlap pooling to reduce the size of the network, and it's reduced the top 1 and top 5 error rate by 0.05 and 0.03 respectively. So the basic feature about ReLU, feature about dropout, feature about pooling layer. So pooling layer also reduce the complexity of the networks, how they introduce that and how they are using. That's we're going to discuss now. Most of the network, the image size to 225 into 225 in the latter, but that time the AlexNet use as input fixed input size 227 into 227 by 3 channel of image RGB. That image, and they use the big kernel size 11 to 11, and the first convolution layer they get in the result 5 into 5 into 5, and the filter number of the filter is depth, we can say the depth is 96. Then they use the polling layer, and polling layer most of the stride will be 2, and the size also the network will be reduced 2 into 2 27, and depth also same. And they use then the same padding will be the same padding they are using there. Same means the padding is the same 5 into 5. Same means here input, if the input this layer for this convolution layer input 27 into 27, depth is 96, and padding same means output should be also same same size like 20 into 7 27, and but here they are increasing number of the filter, they are getting more filter, then they increase the depth to 56. Again they using stride 2 max pooling, then again downsample the network and reduce the complexity and getting the better result, better it will move faster, and there are no loss of also feature also. So 27 and 27 they are getting 13 into 30, and depth also same 2056. Then next convolution layer, especially that convolution you use for only the getting the best feature map. However, they can best feature map here, they convolve the feature again and again and again. So that that is convolution layer 3, convolution layer 4, then convolution layer 5, especially used for extracting the feature map with more depth. So input size will be the same 13 to 13, but the filter size increasing and depth increasing 384, and then they convert the feature 384. Then they change uh, they change the number of the filter, and they are getting the less depth. And finally they use max pool and downsample the network. Then they downsampling, they getting the feature map with 6 into 6 into 6 to 25 with depth. And after that they are using two fully connected layer uh, with this number of the parameter, then another fully connected, this 4090 parameter, then third. So they use three fully connected layer, then finally soft max for getting 1000 result. So 1000 here, ImageNet dataset has 1000 classes, 1000 class. So for example, cat, dog, animal, such kind of image dataset is available. So they have 1000 classes, then we need 1000 class output, so we are getting that. So this whole of structure of AlexNet, and I'm just briefing, I'm telling about that time about 90 epoch, they taking around 5 days around the time they're taking such kind of the time for run 90 epoch with ImageNet dataset. So still this network, like this network is taking so much time for training training. So that's why another people the team work with 2013 2014, and results they with depth, also with computational problem, and with the how to reduce the error also and increase the accuracy also. The next paper will come. So yeah, but AlexNet, the whole idea, and the VGG and inceptions and other outfit, they are whole the network getting the idea from the AlexNet, and they build their custom network, and they much popular and won the competition of this competition regularly. VGG is the second winner of 2014, and GoogleNet is the first winner of image that ILVRG competitions. And ResNet is the solve the more go deeper, like Inception, go deeper problem and get more results, good results apart from this 6.7 accuracy. If you go deeper, then yeah, 3.57 accuracy, but yeah, layer also increase. Here ResNet people are using so much layer, around 50 layer, 100 layer, 1000 layer. They are trained in the deeper mapping, usually using the shortcut connection of residual shortcut connection. So this is about basic about AlexNet. So all of the architecture we discuss about AlexNet and the basic things. Then all the session will cover. Thank you so much watching this video. Thank you.